This video will help you find the value given the highest percent in the standard normal curve. So recall that beef cattle is normally distributed and had a mean weight of 1,152 pounds with a standard deviation of 84 pounds. What is the weight that represents the highest 10% of the weights? So again, we're looking at this, we're trying to find the weight or the value that's on our actual number line form that represents the highest 10%. So again, I'm going to symbolize this by looking at the picture. Hopefully you remember from your notes that the mean represents the 50% below and 50% above. So if I'm looking at the highest 10%, I'm going to be to the right of the mean, and I'm interested in that percent that is above. I'm trying to find or identify the weight of the steer that represents that highest 10%. Hopefully you remember this normal probability table only gives us values that are below a value. But we're given a percent that is above a value. So we need to identify the percent below so we're able to use this table. Again, hopefully you remember from your notes, the normal curve has 100% of the values below it. So in order to find the values that are below that marker, we're going to do 100% or 1 minus our 10%. So we're really interested in looking at the lowest 90%. So the highest 10% is the exact same thing as saying we are interested in the lowest 90%. So really that's what we're going to go about and we're going to do here. Again, remember, watch the last video if you don't remember how to do lowest, but we're going to go through it go through it very quickly here. So we're looking at 90%, 0.9. Remember, in our table, we're looking in the bulk of the table for the percent. Remember, the percents are in the bulk, the z-scores are along the side. This table, again, will only give us a z-score, so once we have our z-score, we will need to convert it to an actual weight. So we're looking for 0.9 in the table. Again, the highest I see here is 0.4641. So I keep going. 0.9, 0.9. So it looks to appear to be between, in this area, is where the 0.89s change to 0.9s. So we want to find the value closest to 90% or 0.9. So we're looking. We have a 0.8997. Then it goes to 0.9015. So we need to determine which of these two values is closer to 0.9. 0.8997 is closer to 0.9 than 0.9015. So 0.8997 is the closest percent to 0.9. We need to identify the z-score that matches up with that percent. Again, that comes right from the table. So I go across my row first. We know it's 1.2. And then we're going to follow that 0.8997 up the column to 0.08. Add that 0.08 to 1.2. You get 1.28. So my z-score that matches up right here is 1.28. But again, that is not the actual weight. We now need to take that z-score and using the z-score formula, convert it to a weight. So we're going to use the z-score formula of z-score equals value minus mean over standard deviation. We know our mean is 1,152. We know our standard deviation is 84. We know our z-score is 1.28. So our z-score, we can fill in 1.28. We are trying to identify the value, or the x. Again, now it's just simple algebra. To get rid of a fraction, multiply by the denominator. Whatever you do to one side of the equal sign, you have to do to the other. 84 times 1.28 gives us 107.52. The 84 in the denominator and the 84 in the numerator cancel out to give us x minus 1,152 on the right-hand side. And then to get x by itself, we're going to move the 1,152 over by adding it to both sides of the equation. (107.52) plus 1,152 gives me a weight, oops, I got super excited, of 1,259.52 pounds. 1,259.52 pounds. This is the weight of the steer that represents the lowest 90%, which is the same thing as saying the highest 10%.